welcome to this episode number 4 of the series, which is about intro demo coding. So we will continue with the series related to the demo or intro coding. Anyway, let's go to the browser. So, as always, please like and follow the Phase 101 YouTube channel, subscribe to it and like the videos. This is the only way I know of how I can share our love, let's say that, for the Amiga or the Commodore 64. You help me share the videos by putting a like. Under each video, I remind you that there are the chapters. Okay, you can select which part you want to view or listen to, but also there are links to, let's say, the playlist, let's say the source. It depends which video you are watching. So I have yesterday released the last episode of the Let's Make an Amiga Game series. Hello, Dockster, where you find all the code related to that series, where you find all the videos related to that series, and you also, on itch.io, there is some more information related to it, and you can also actually play the game. There's an ADF file or an exe file, depending if you want it on a hard drive or on a floppy, and you can play the game. Although I'm saying it's finished, I have the intention of improving it, but in terms of game core, that's it. Or what I will do, I will improve the nice flashy things. But for that, I do not need to waste more, let's say, coding series. It's just making it more nicer, and whenever it's ready, it's ready. May I remind you that I have the Facebook page where everything that I do goes there. I wish to have a blog, but I do not have time for a blog, so it is my blog. I also have the Phase 101 Facebook group and the Commodore Dev Facebook group. Both of them, one is related to Phase 101, of course, only, and the other one is related to anything related to Commodore. Guys, if you want to talk to me, you can talk to me on Facebook. Many people send me messages on Facebook, but in reality, I take time to read them. I only read basically Discord or Telegram. If you join the Telegram group, which I'll mention in a minute. I only read Facebook when I go on Facebook, but it's not every day. And when I'm working, it's very difficult because they do not like it. But if I am on, Discord is easy. So yeah, I do suggest if you need any help or so, I'm always willing to help everyone. So that's the quickest way. As I said, I have a Telegram Phase 101 group. It's it's new. It's having been there for long. So it's still in the initial phases of it, and some people just do not want to use neither Facebook, do not want to use Discord. So yeah, at least you give them Telegram. Those that are supporters of mine, I don't know if today you have noticed, you should have received lots of alerts that I've been adding videos to Patreon and Coffee. So yeah, if you decide, if you like what we do and you want to support us. You will unlock 70 more videos. There is more which I haven't released yet. Didn't have time, but at least I incremented the number of videos on Patreon. Not all videos goes on YouTube. Okay, so you will not, I'm not always releasing all the videos to YouTube. Some remain locked for Patreons, which is fair, I think. And it's another copy of the same thing. There is coffee. Okay. I believe that's all. So we can jump to Visual Code. Hello, everyone.
Hello?
Hello, can you hear Ozzy?
Check, check, voice check.
Okay, guys. I'm hoping that all is fine, since I haven't seen any messages from you guys. Okay. We are in lesson, it says 8 and 2, but as usual, but we should be in lesson 1. Let me check. Yeah.
Yeah, I'm recycling over and over.
Yeah, I realized to
the same
confuse me. Okay, thanks, Dapper Software, I assume. And is it your first time being here? I don't recall. But anyway, welcome to the stream. So, guys, I need to start the Amiga also, no? I forgot that.
Yeah, and the PDF.
Yeah, and I need the PDF. The PDF is already there. Should be there. Yeah. But the Amiga is not. Okay. Okay, sorry, my friend. I must have missed your presence, but yeah. Thank you for being here. So,
Yeah.
this is episode number 4, and today Ozzy is going to start teaching us more things related to intro coding. This is theory, which I mean, we have examples also, so it's not just theory, which what we saw in episode 3, okay, of how he built his framework and how we can pass parameters to his framework to do things. Now he's going to elaborate more and why we have these things, okay, and some maths theory behind it, let's put it this way. So without any further ado, let's pass to Ozzy. In your hands, Ozzy.
Okay. Yes.
Yeah.
I didn't got what you said last sentence.
I said you can start.
Okay. And I will. So, welcome back, everybody. Sorry if I missed last week. I was on vacation in Switzerland, but now I'm back. And today, well, while on vacation, I prepared this, I would say, short speech, and it's about vectors. And before starting, I'd like to just make a, let's say, disclaimer, because I'd like to quote the sources of what I do, because it's not work which comes out of from my mind, but as it usually happens, it's just my re-elaboration of some something that I read on the internet, or in this case, it's about this book, and I don't want to make
no,
advertisement.
you were too fast. Can you hold it a bit longer so that the camera
Yeah,
will focus?
yeah,
Ah,
this is
the
a
nature
very
of
good
code.
book.
Yeah, okay.
Yeah, you see mirror the probably. Oh, no, you see it right, but so this is a book, and it's not about Amiga, of course. It's about the nature of code. So what it does, it explains some concepts, and it explains in a language, in a modern language, in pseudo Java, C++ language, but I don't really care because I just want to understand the basics and then reapply on Amiga. So that's it. Uh, that's why I'm reading it, just because I want to do what is written here on the Amiga, because it's very simple to understand, and the first chapter of this book is about vectors. So what is a
But by
vector?
who is that this book written?
Uh, can you repeat, please?
By who is the book written? Who wrote the book?
It's Daniel Schiffman.
Ah,
It's
okay. He is the
it's
guy that
a
does processing. He has lots of videos
yeah
on processing. Uh-huh. Yes, I
yeah.
know the guy.
He's also a YouTuber.
Yeah. I know the and as soon as you read the title, I realized that it's probably him, but I just wanted to confirm.
Mhm.
But yes, it's a very good book. That book.
Yeah, yeah. I like it, and I started reading it because I had to solve one problem while doing my demos, and the problem was how to move object uh, in the screen, because I want to move, at a certain velocity, and I want gravity, I want friction, I want the concept of mass, I want so a very basic bare bone, bare metal physics engine that can be computed also with an Amiga. And so I don't know if you remember the demos that I listed on my first appearance
Yeah.
here, but there are two in particular that uses vectors to simulate gravity. You see this bouncing ball that
Yeah.
hits the ground and then goes up, and then there is a wind, and then they goes up, forward and backward. So they are just hardware sprites, so nothing fancy. My addition here with this book is how to represent all these forces in the demo.
Mm-hmm.
So this is why I was so interested in vectors, and maybe I thought you could be interested as well.
Yeah.
So
The book is available for free, if I remember, online, but
it is.
it is available for free, but the PDF version is not available. You have to buy it. But if you go on the website of Daniel, you should find the book. I will look it up later on, and maybe we share it in the future. But yeah, the book is for free. The only thing is there's no PDF of it. It's just it's online. It's an HTML book.
Yeah. Also, the very same concept are shown also in his YouTube videos.
Yes.
If you want to go a little bit more in depth and do a follow up or
Yeah.
something, the book is perfect. I bought it because I want to support Daniel, but okay, well, feel free.
And he does everything with
I'm not
processing.
suggesting to buy anything right now.
No. And he does everything with processing. So that's why I know I know Daniel.
Yeah, and I want also to add that my framework is called AProcessing. I just put an A before,
Yeah.
just because
Now it
I'm
makes
just
sense.
retro-engineering processing for the Amiga. So I want to look like more or less the same. So the name comes from there.
And now it makes sense that you said it makes sense. Even the functions now is going to make sense, I guess.
Yeah, I copied the name, but of course the
Yes, now
implementation
it
is
made sense to
completely
me.
different because you can't use object on Amiga, or
Yeah,
at least in assembler. You can use some data structure that looks like something like that,
yeah,
but it's not really possible to do copy and paste of the code. I have also to take shortcuts in some way because the computation was very hard for the Amiga
yeah.
in some situations. So this is just I recycled the name and the main concept, the very base concept, and that's it.
Hmm.
It's all mine. I didn't steal anything other than that.
No, but it's cool that you did this actually because he does really good things. I mean, Daniel is one of those people that I do follow. So yeah,
Yeah, he is quite popular on YouTube, I think.
yeah,
I don't know. Well, let's. I would say we can start with these vectors.
yeah.
So uh, the book states what is a vector, and in this chapter I will go into Euclidean vector because there are a lot of type of vectors. I remember where I was at school, my teacher taught me that vectors are so it uses the word vector for arrays, and it just makes some confusion on my mind, but that's it. In this time, I'm not referring to array, I'm just referring to vectors. So entities with, as the book states, they are object with direction and magnitude. And they are typically represented with an arrow pointing from A to B. So for me, it's just how the representation, the internal representation of the Amiga, how can be moved object. So we have, for example, a ball which is on point A, and I have a point B. I want the ball to go from point A and point B. I want to represent this movement, and for me, the vector are a pretty good solution
Hmm.
because they are, at least at this level, they are so easy to use, and so this is why I end up just implementing some vector function inside my A-processing. So inside A-processing to the vectors, because 3D vectors are not implemented yet. I didn't have, let's say, the motivation to implement a 3D vector because all my demos live in a 2D space. 3D requires a lot a lot of additional work for a computational point of view. So I'm just sticking to 2D vectors, which are much easier. And in when you build a vector with my processing, you are just reserving a long word in memory, and that's it. The, the first two bytes represent the x coordinate of the vector, and the last two represent the y. So it's really just a couple of values, and it's just a convention because all my routines knows that the x position is at address 0, and the third and the fourth byte represent the, the y position. And you can also think a vector as the difference between 2 points. In the above example, A is the starting position, and B is the destination. This is what I just said. So it's
Okay.
not so hard to understand. We have A, which is at point xy, and we have B, which is at point x1, y1, and the vector is just the difference between these 2 points. That's it. Please turn the page.
Okay.
So these are, of course, this is not a full comprehensive list of vector operation, but this is what I'm planning to do in my framework, because these are the most used functions. And there is a creative 2D vector, which is just reserves this 4-byte contiguous area of RAM for a vector. You can add 2 vectors, and we have the add 2 vector routine, and we have the add 2 vector static, which does the same job, but the difference is that it works like the add or sub instruction. In Motorola, you have a 2-operand instruction, and the second operand is also the destination. For example, if you say add D0, D1, the D0 is added to D1, and the final result is into D1. So you are recycling the second operand. And this makes the code, the binary code, so clean and small and neat that likes a lot the Amigans. And this is the same concept. If you want just to add A to B and B holds the value, you must use the add to the vector. And if you don't want the second operand to be altered, you just the static version, and that's it. Same exact concept for sub D. Okay, it's missing a 2 here. It's sub 2D vector and sub 2D vector static, and the multiplication and so on. So the div 2D vector is to be implemented, and a lot of other things has to be implemented because I didn't need them, so I neglected to implement all this stuff. Of course, if some of you has some interest, for example, the limit function should be very easy to implement. If somebody here wants to do it, I will accept pull requests or suggestions and so
Hello,
on.
Dario.
Did you said something?
Yeah, I said hello to Dario.
Oh, I invited him, but he was busy at the cinema. I'm glad that he came at least. So, as I said, this is a pretty short list, but for me, it's more than enough just to move something on the screen, because you don't need all this stuff that is inside the processing.
Can I suggest something? Can you move, I don't know, can you move the tablet?
Oh, yes.
Because your face is,
yes,
you're hiding your face when you move backwards.
Of course, because, yeah, I'm using another webcam. I have to get to.
Okay.
But yes, I will stay still.
Well,
at least I'll
but
try.
You know what I mean. Do you want to change the page or stay on this one?
No, I just want. No, yes, you can go on, and I think we can jump straight into the examples because I don't want to spend a lot of time. So this is my example 1. It's a basic vector plus a random vector. So what we are going to see now is just reusing all the concepts that we saw on the last episode. So what is a translation? What is how the line function works, which is very basic, very easy to understand. And we use the translate to translate into the center of the screen. and row 105 is where this is implemented inside our example. And then we create a vector v minus 100, 50, and this is implemented at row 134. And then we draw from the origin, and this will reveal the vector. I did this because for me, seeing abstract concept visually helps a lot. So if you see a line which is representing a vector on the screen, is something that for me is good. It helped me to reinforce the concept. Okay, you can go to VS Code and show the example, and we can comment my code. Okay, go to where is the translate function, which is, I don't remember the
hold
translate.
on. Because I cannot have both things on the same screen. You have to, here it is, tell me.
Okay, you go at row 134. Oh no, yes, before we must go to 105, sorry.
So first we have to go to 105, yeah. And what do I need to do?
Just highlight this line. And this is JSR translate, so we are jumping to the translate routine. The translate routine I will repeat because maybe not everybody followed the previous episodes. It will change the origin of the coordinate system into something else. And in this case, the input data is in data register D0 and D1. So width is just a equal directive. So we are storing in D0 the value of 160 because it's the X center of the screen. And on D1, we do the same thing, but with the vertical resolution. So we are saying that we want the origin of the axis is at the center of the screen at position 160 and 128. Then we use the stroke macro, which tells which color we want to use. And in this case, since we are in a 2-bit plane system, we are using color number 3. And then we say line draw. So this is just my routine that uses Bresenheim. It's not using the blitter to draw a line. And notice that we are drawing from 0, 0. And 0, 0 is not the upper left of the screen, but is the center because we used the translate before. And we are, this is just a line that I use as a reference. We are drawing from X0, so the center of the screen, to -8. So it's just a reference. It's not just part of the demonstration, sorry. What I want to show you is the following, is the Lia vector 1A0. And this is where we just create the vector. So at line 112, we load into A0 the address of vector 1, and then we put in the 0, which is the, let's say, we are loading data register for the next routine. We are saying we want to create a vector, which is at position -100. This is the X position, and the 50 is the Y position. And then we create the routine, create 2D vector at line 134. So the point is, to create two vector routines wants to know two coordinates, the x and y. The x is minus 100 and the second is 50. And we are instructing this routine loading by data register. And that's it. After the call create 2D vector, we have a fully initialized vector, and we draw a line using this vector. At line 139, we say, okay, we want to draw a line from x and y position 0, which is the center of the screen because we use translate in the middle of the screen. And then we want to draw this line from the center of the screen to the vector coordinates. And the x vector is just 0 and y vector is 2. These are the memory offsets. Nothing fancy, really. And if you run this code, you should see a line, the first line, which is just a reference, but what it does, what it matters most is the second line draw that we will plot, let's say, we'll draw a line from the origin to the vector position, and this is my vector representation.
Okay.
Don't forget to assemble it.
Yeah. That's our code. That's your code.
Yeah. So what is relevant here is the green line. As you can see, the green lines, as I said before, it starts from the origin and it goes to coordinate minus 150. Always remember that the y coordinate system is inverted because that's how the Amiga works. So if you are adding to the y, you are going down and not up. It's a bit counterintuitive for me, but that's how computer graphics usually work. So the first line, the blue line, is just a reference, just to realize where is the center of the screen, and the green line is my vector representation. I think it's very easy.
Mm-hmm.
Now, in the PDF, I suggest, as I always do, to play around with my codes and try to break things, which is the funniest part of the Amiga.
What does it say? Let me check. So
and
in the PDF you say, to have fun, first uncomment rows from 116 to 112, and from from 116 to 122, and from 126 to 132. So
yeah.
So okay, these. Okay.
Yeah, if you see that there is a jump into location XOR 128 gen, and this is a routine that I copied and pasted from EAB, which is a popular Amiga website forum, I think. And what it does, it just generates a random number.
Okay.
Okay. So what I'm doing here, I get a random number and I override my data register. So each frame we have a different vector.
Yeah.
Let's hope.
So first one, oops. And let's still the same. Hold on, of course. Ozzy, you should tell me to save.
Yeah, also save.
Yeah, sorry, I forgot to save. So let's run it again.
Now I know why
There,
Pellicus uses live coding, because
there you go.
if
It's generating,
yeah,
it's generating the random vectors. Um,
yeah, as you can see, it's the starting point is fixed because it's a
yes,
constant, is always 0, 0, the
yeah,
center of the screen. And these are just some random vectors thanks to this random routine.
yeah.
Oops, or
By the
what
way,
I call it pseudo random because it's not really random, it just
yeah.
looks like random.
By the way,
Okay.
the Amiga that I'm running is a 68030 today, just to make you aware.
I think the final outcome would be the same on any Amiga, I
Yeah,
think.
just to make you aware, just in case.
Yeah, no problem. My code is strong as a rock.
Well, it's not that,
So,
but if you are surprised by speed, I'm telling you it's because of a 68030.
okay. So now you may wonder why I'm showing some random vectors. And the answer is, you see that every vector has a different length. It can be short, so the end of the vector should be near the origin, or it could be very far. In the code, I limited the random number to not be greater to some certain value. I don't remember which one, just to do not go outside the bit plane,
Sure.
the bit plane error. But as you can see, there are different lengths, and usually the length in this case in a vector is called the magnitude. So the magnitude is just how much is long this object, and that's it. And if you can think
Can I
about
can
it
I can I
for a
ask you a
moment,
question then?
it's just a triangle,
Yeah.
and I don't know how to say this in English, but in Italian is the ipotenusa. Hypotenuse.
Hypotenuse. Hypotenuse.
Okay. Yeah,
Hypotenuse.
it's the hypotenuse of the triangle.
Okay, so
And
can I ask you a question then? So
yeah,
the vector has got a random magnitude. Okay, the point of origin is always the same, but has got a random magnitude and a random direction, right?
yeah,
Okay.
yeah. This is the point of this example, just to show a bunch of different vectors
Mm-hmm.
and to see the vector visually. And I think it helps a lot for learning.
Yeah. Okay.
And I'd like also to make another change to this code
Yeah.
and comment the clear top as instructed in the PDF.
Clear?
Open the PDF.
Yeah. I'm seeing it. Don't worry. It's not closed.
Oh,
It's just that it's on another
oh,
matter. To have more
okay,
fun, comment clear top at line 96. Okay.
right. And just to make this more evident.
Remember, I need to save.
Yeah,
If it does the same thing, tell me, did you save? Okay.
yes, Control S is your friend. And also you have to compile after saving.
I thought I did it. So, yeah, there you go. Guys, you've seen this many times in demos.
Yeah, the flickering is caused by the double buffering. Don't pay attention to this flickering. But the final outcome should be something that resembles like a square
Yeah,
because of
eventually.
the limitation of the magnitude.
Yeah.
And you can see there are smaller vector, longer vector, so magnitude with near to 0 and magnitude that goes up to, I don't know how much, 120 probably. And of course, if all these vectors were limited by the magnitude of the vector was limited by some number, you will end up with a circle instead of a square, because you are at the end, if you think about it, you are just drawing the radius of a circle.
Yeah.
If every line has the same length, that is to say the same magnitude, you get a circle. This is just a representation. Since we are not clearing the screen on every frame, we see switching from the memory area buffer 0, buffer 1 continuously. This is why the flickering. And of course, since we are not clearing the screen, the more the time goes by, the more this area will be filled, and it should resemble even more to a square. So it's not so complicated to understand. Right now, I'm just drawing lines. Each frame, it's a new line, and I'm not deleting it. This is why the image is filling. In the next example, I think we will see the same exact concept. Okay. I think the minds of the eyes of the viewers are flashed right now, because this is like
Well,
too much to handle.
you can put it behind your head, and they think that you are some prophet or something like that.
Yeah.
So let's bring the slides again.
Yeah, let's read the following page on the slide before proceeding.
Yeah, this one. Yeah.
Example 2.
Yes.
Okay, this is the same stuff from example 1, but we this time we call set to the magnitude to illustrate the concept of a magnitude. So at line 135, we limit the magnitude of the vector. This is done first by calculating a unit vector of length by 1, and then scaling. So I'm just, first I find the unit vector, and then I tell how big is the magnitude.
Mm-hmm.
And I use some number just to scale. In this case, I used 100. So it means in the following example, you will see each vector will be of magnitude 100. But the point that I want to highlight here is that when you go to school, they told you how to calculate the hypotenusa. I say in Italian because in English it's too much complicated. Mm-hmm. Yeah, and it requires you to use square root, because you have to multiply x for itself plus y multiplied for itself, and then calculate the square root. And for the Amiga, the square root is, let's say, hard. There are some routines that are trying to implement square root, but for a demo scener, the square root, at least for me, let's put it this way, I don't know how to calculate the square root. I found some routines on GitHub, and they work quite fine. I don't know the precision, but still I'm not satisfied with the result. What I usually do is I just do the sum of the cateti. I don't know how to say cateti in English, but the final result is not much accurate, but it's very fast. This is how I calculate the magnitude. So it's not 100% very precise. Of course, Dario uses lookup tables. You can also go into this way, but I try to avoid using them as much as I can, especially when I do side coding. But yes, lookup tables are another possibility if you know in advance what kind of numbers you are dealing with. So, but by the way, I don't want to go into this territory right now. I just want to show you how I calculate this square root. And so open the code.
Yeah. Hold
Because
on.
at the end, I just want
number one.
to...
Hold on. We are still in number one. Okay. Now we are going to be in number two.
Right?
Uh-huh.
As I was saying, for me, the important today is just to teach what is the magnitude and know not how to build lookup tables and how to deal with this stuff. So I'm just repeating the concept of the book. And so I think, I don't remember which line is the magnitude. Is that magnitude?
So I do not run it. Should I run it first?
You can run it, yes.
Mhm.
Of course, and then we can comment the code, which is very similar to example number one.
This is what I have. Is this right?
Yeah, this is right. Now, of course, it's not so evident because it's going too fast, but all these vectors should have the very same magnitude. So the length should be pretty much the same. And if you comment out the clear top at line 96, you should end up with something like a circle.
Okay, so 96, you said?
I think it's always the line 96, or just search for the clear top occurrence.
Yeah.
And it should be.
It's 96, yes.
And then, of course, save.
Yeah. And now let's bring the Amiga back. There we go. And we have seen also this many times.
Yeah, it should see like, it should be like a circle. And of course, as you can see, there are some lines which are a little bit longer than the others. At first glance, for me, it's a big error. And I don't know if it's caused by my roundings or if there is actually a bug inside my set magnitude routine. But at least it's for my needs, it's quite fast and quite enough accurate, and I can live with it. Of course, if I want to do or want to have some more accuracy, I will end up using lookup tables as suggested. But as I said, I don't like lookup tables. I uses them only when I'm really forced. Just a personal of a matter of taste, personal taste. And can you go to the code, to VS Code, please, and go to line. Go to 136.
136. Yeah, there's nothing.
Come on.
Yeah,
136. 35, pardon.
Yeah.
And this is what the main difference between example number one. I think it's the only difference. from example number 1, we are loading the value 100 into D7, which is the input that register for set magnitude routine. And then the seg2d magnitude will alter the properties. So it means it will recalculate x and y according to the magnitude with all this math that I discussed before. And this is very trivial, not something that is rocket science or whatever. I just do the math, and the only problem for me was just how to get the square root. You can say to AProcessing when you compile, you can add some defines -d, and with them you can specify how much accuracy do you want, and you can set it with maximum, and of course the performance will decrease. But anyway, it's not something that I want to show. Probably this is still not very good because the rounding error was too much. Some lines were significantly longer than others, but okay, for me, just to show off what is the magnitude. Can we go back to the PDF, please?
Mm-hmm.
Okay, I think you did all this page. We can go to example number 3. And we are starting to use vectors for what I need. And we are talking about position and velocity. So let's try to imagine that you have a sprite on the screen, and each sprite has a position, and it's stored, of course, inside the sprite data. So I have my routines to translate from a vector to a sprite, but is this another story? What I want to show is that vectors can be useful to represent and calculate movements. At least this is how I use them. A position can be thought as a vector, and the velocity is another vector. And for me, the position is changed every frame by velocity. So velocity describes how the position goes in time, how the position is changed over frames, one frame to frame. So each time I add velocity to the position, and I do this with vector. In this example, I create two vectors. One represents the position of an object, and the other a constant velocity. So we are moving constantly, and you can see it at lines 96 and 102. Okay, we can go for a moment to VS Code.
Mm-hmm. Hold on, because I need to load the third example.
Okay, if you go to line 93.
Yeah.
And this is the very same stuff that we saw on the other example. We are loading a position into A0, so it's just a memory region. And then we create a vector with coordinate 0, 0. So this is our starting position, which is the center of the screen. Again, because I think we have a translate. I don't know. We don't have a translate. It's just an empty 0, 0 vector. Okay. Then we have another vector, which is called velocity. And this describes how the position changes over time. Or in our case, we don't have this time concept. At least I use the frame concept. So after one frame, the position will be to 1, then for 2, and so on. And this calculation will create the illusion of a movement. And okay, we create the vector, and then there is also a set magnitude if we wanted to speed up the movement. And that's it, I would say. I think that please go back to the PDF because I don't remember what this example is doing actually. So inside the loop, and when I say the loop, it's the game loop. So where you check if the left button of the mouse is pressed or not, and you start over. The velocity is added to the position and at line 139, and the outcome of this operation is passed then to translate. And this will cause the square drawn at 156 to be moved according to the velocity for the initial position. So we can see right now, go to line 139, and this is the interesting part. And this is my routine for adding vectors. It's just to add the instruction, nothing very interesting, but this is how it works. You load the vector number 1 into A0, you load the position into A1, and you add them. And notice again that when you call add to the vector, the final result, the outcome of the routine, will be stored into the second parameter, which is the vector inside A1. So here we are just telling each frame, please add velocity to position. And then we have this position vector, which is increasing over time. And the content of the position vector are then stored inside are just used to feed the translate routine. So we are changing the origin of the coordinate system according to this vector. And then we draw a square at line 156, and this is some routine that we already saw on the past episodes, I remember. We are just drawing a square which is centered according to the origin. So since the size is 20, we must subtract -10, and this is -10 and -10 are the XY position of the upper left of the square, and the 20 is the size. So this makes the square centered. You can try to run this demo, to compile it, and we will see that there should be a square moving to the right, from left to right. And also, I think in the bottom, because this is how the velocity is doing. Yeah, I also included my clipping routine because otherwise the square will go off the boundaries. But this is how it works. You can try to change, for example, the velocity. For example, try to move toward the up. You just have to change the velocity vector at line 101.
Of course, 101 is always important.
Yes, I think it's a coincidence.
Okay.
Yeah, we can put whatever value you want. You can put 2, you can put -1, and if it works with negative numbers, the square will go up.
Uh-huh. Okay, let's do
And
-2 then.
yeah, you should get some diagonal towards the bottom of the screen.
Did I save? Yeah. And compile.
In Italian, this is called the bisettrice.
I don't know. I really did not understand that word, but it's okay. There you go. Now it's going
Yeah,
up. Yeah.
up.
Yeah, it's going up.
Okay, it doesn't work. It should go down.
No, because we did minus. You told me if I do minus, it will go.
Ah,
No.
okay. Oh,
Look.
if it's minus, of course, it must go up.
Look, look, it's here. Oops, it's here, look.
Yes, -2. Yes, it's always a bisettrice. But blame me, I was not paying attention to your code. And that's it. This is a constant movement. And let's say I have in mind, for example, a video game and the movement of the sprite, let's say my platform games, just the vector should reflect what the player is doing with the joystick. This could be a possibility, maybe, I don't know. Maybe in the future I will do something like that. For now, I use this technique just to get these bouncing balls on my demos. And that's it. What else do we have on the PDF?
Let me move this. I'll get you the PDF. So we did this part, no? We did this part.
Yeah, so, okay. Notice at line 139, add to vector behavior, okay. So, okay, I think I already said everything. Oh, try to change values at 100 and 101. You did it on
Yeah.
101 to change velocity
Yeah,
and
okay.
see how it behaves. So I think we did
it.
all of that.
Yeah.
And I think we can go to the next page, which is example number 4.
Mm-hmm.
And this is something that I just want to discuss a little bit before running the code. So the example is is the same, and the same concepts are applied. We still have our square, which is moving across the screen at a constant velocity using this velocity vector. But one of the problems that I encountered while developing on the Amiga is, what if I want the square to have a velocity, for example, 1 pixel every 2 frames or more frames? Okay, I must have a way to represent a decimal number. For example, I want to travel 0.5 pixels each frame. And of course, this is not possible with the example that we saw at example number 3, because when you feed the vector, you give integer numbers. And so this is why in the second episode, or I don't remember, third episode,
Second episode
I spent
Q
a lot
number.
of time. Sorry?
You mentioned in the second episode, you mentioned the Q and number, Q number dot number.
Yeah, and this is why it's so important to me, the way we represent numbers on Amiga without FPU, because the data can have different meanings according how you use it. you can say, okay, move 1 to the 0, but this one could be interpreted in many ways. Of course, at the end of the day, the register will have always have the least significant bit set to 1 and the other to 0. But what I want to stress is what it does, what this really means to us to have this bit. And this is why I spent a lot of time talking about the fixed point notation and these Q formats and so on. So in this example, the only difference here is we want the velocity to be less than 1 pixel per second. We must use the fixed point notation. At least this is my solution, and this is what I usually do. But maybe there are better solutions out there. I don't know. This is a typo. I picked my favorite format, which is Q10.6. So again, this means that I have a word. I'm reserving 10 bits for the integer part, and the 6 least significant bits are reserved for the decimal part. And this is why at line 150 we have a shifting. And this is another of my problems because shifting by 6 is a problem on the regular Amiga because the execution time of the shifting depends of how much you shift. So every time I have to pick one value that should be good for me and not be so let's say computing have a high toll on computing power for the Amiga. So this time I picked 6. It could be every other number. Of course, the more you shift, the more you get decimal precision. So the new velocity is defined at line 102, and here there is a little bit an explanation. How do I calculate this number? And this is at line 102, I can anticipate it's just move.w 32 into D0. So this means that in Q10.6 notation, I'm just representing 0.5. And this is how another way to make the math, to do the math. Last time I did another method. This is maybe I changed it because maybe for someone this is a little bit more straightforward. So what I'm doing is just multiplying for the position. For the first position is -1, so you do 1 because the bit is set at the left. The most significant bit is set. So you use 1 and you multiply by 2 elevated to -1, which is 0.5. The other digits are always 0, so 0 multiplied for everything is always 0, and so you add 0, which is neutral operation, so you end up with the same number, which is 0.5. The same concept is there for the y velocity. The y velocity in my example is defined as 16, and so this time we have the second digit set. And for this reason, we have to multiply for 2 elevated to -2. And this represents as the number 0.25. And so this example, we are asking the routines to move the square 1 pixel right each 2 frames on the x-axis and one pixel each 4 frames on the y-axis. And I think it's pretty good solution, even if you have to to shift all these digits because the code is very clean and very human readable. At this point, if you want, you can compile this and you can show these lines which are 101 up to 107.
So we are download example 4. No.
It's example number 4.
Yeah. So, and shall I run it as is?
Yes, just run it, compile and run it. And you should see the square which is moving very slow.
There you go.
Yeah, this is the expected result. So we are moving very slow, and now the square is clipped, and it won't come back unless you restart or there is an overflow. But I just want to once again reinforce the concept which is shown at line 101, and I want to make clear that how do I represent this type of movement, because it could be counterintuitive for maybe a C programmer, for example, because usually C programmers or high-level programmers don't care about these problems. They just type double x equals something and that's it, or float x equals something and that's it. In this case, we have to figure out something to do this type of stuff. So please go to line 101.
Is this a coincidence or you made it intentionally 101?
I repeat, it's just a coincidence.
That's how important that number is.
Yeah, you said I use a multiplier, which is a directive,
Uh-huh.
and I think it's defined at the top of the file as 16. You can try to change a multiplier. For example, you can set it to 8.
Where is it? I do not see it.
It should be defined somewhere. Otherwise, VASM can't understand. Just search for the occurrence multiplier. Yeah, that's it.
That's it. Ah, it's there. It's
Multiplier.
it's
Yeah, it
Q16.
was. Sorry, I tricked you. It
Yeah.
wasn't at the top of the file. It just before the code. You can change it to 8, for example,
Uh-huh.
and you will go much slower with 8 because you are representing lower numbers. It's 0 dot something, 125.
Okay. Let's run it again. Hold on. You forgot to tell me to save.
Oh, sorry, it's my fault. Please save. Control S.
Yeah. You know why I don't do it? Because normally, in my way of working on the Amiga with the extension, it saves automatically for me. So that's why I'm not doing. But with your code, I need to save before.
Yeah, I do this stuff also on a real Amiga on DevPack. So there is not no autosave
Yeah,
in
yeah, yeah.
Amiga.
Oh God, yes, it's very slow now.
Yeah, because you are the speed vector is a very weak magnitude right now. So if the magnitude is short, the square will move slowly. If you set a very high magnitude, you see the, the square will go out of the bit plane very quickly. And that's it. Uh, I think we can, unless you want to play again with this vector and you want to set crazy numbers, we can go to the
Uh,
next.
if you want, I can do that, or if you want, we move to the next one. It's up to you.
Yeah, just move to the next one because I thought that with only 5 examples, it will be very quick, but
No,
still
I
we are
told
approaching
you.
midnight. I
Yeah.
don't know how is it possible. Maybe I'm too much verbose.
Okay. So there you go. Number five.
Number five, acceleration. So this is the last topic of today. And of course, I represent acceleration with another vector. So we end up with three vectors. The first one is position. The second is the speed vector. And then we use acceleration. And what is acceleration is just the change of the velocity over time. And again, we use to represent acceleration, we use a vector which is added into velocity, which ultimately adds to the position. And with this technique, we can see the square which speeds up across the screen. Uh, and all this is implemented at line 145. I would say let's go there. Oh, I just discovered that bisettrice in English is bisector or bisector. I don't know how to pronounce it. Thanks to
Which
Pellicus.
145?
Line 145.
Yeah.
Yes. And this is the interesting part because the example is always the same. Every time I just add or change a tiny portion of code because it makes me feel better. And for me, it's also easier for the viewers. So we have the acceleration vector, which is in A0, and the velocity vector, which is in A1, and then we add them together. The final outcome goes into the velocity vector, and then we repeat the process. So the velocity goes into the position.
Mm-hmm.
And then the final position vector is used to feed the translate, and we are changing again the origin of the axis, and then we draw a square, and that's it. No black magic here. Very simple and straightforward, and you can compile it and save it. No, you don't need to save it because it's the first time. While you run it, I will take some water.
Mm-hmm.
You see, it's picking up. There
Yeah.
is some glitching because when there is off-bit planes, there must be something wrong. But the concept is that the square will speed up
Yeah.
constantly, and this is the point of the example. So
Well, there you go.
um, I I don't know if there is something to add. Now it's crashing probably. I don't know what it's doing right
No,
now,
no,
but
no, it didn't crash. No, no, no.
if it doesn't crash, it means that my clipping routine is very solid. So I'm very happy. And let please go back to the PDF and see if I missed something. So the velocity vector is added to the position vector, and we saw it. The final result would be a square accelerating according to the acceleration vector. The clipping algorithms will do their best to prevent the program from crashing, and this is true, I think, since the square is going out of the bit plane bounds. Still, there is some flickering. I don't know why, but it's not important. Probably at some point we have some overflow and crazy, strange values inside the word of the vectors, and this is why we had the flickering, but that's it. These are the main concepts that I wanted to show off today, and I want to repeat myself. This is what you just saw. It's just the first chapter of this book, and this is my version adapted for Amiga. And nothing more, nothing less. Of course, the book goes into details and explains what is a difference of vector, which is what is a dot product, how to do vector multiplication. But at the end of the day, the main concepts are the same that you saw today. And that's it. I would say thanks again to Daniel Schiffman for his book. I am planning to continue because on chapter 2 of this book, the book uses vectors to represent gravity, friction, winds, other natural forces, and probably this is why this book is called The Nature of Code. Probably, I don't know, but that's it. I hope this was interesting to you. I did my best.
Okay, no, thank you very much. It's interesting, of course. So, guys, thank you very much. I hope to see you tomorrow in the stream, the Italian version, or in the on Sunday. In the meantime, I thank Ozzy, and also thank you for the patience for being us with here and listening to us. Uh, talking about vectors and all that stuff on the Amiga. So thank you very much and see you tomorrow or Sunday. Thank you. Bye bye.